Hello everybody, welcome back to another NumPy video. In this video, we're going to be computing an exact probability. So in particular, we're going to be answering exactly the question, what is the probability if I roll 4 distinct 6-sided dice, that the biggest value that shows up is a 5. So again, this is the same question that we asked in the last video, except now we're going to be computing the exact probability instead of just an estimate. And part of what makes this possible is if we think about it, so I have 4 6-sided dice. So that's 6 to the power of 4 different outcomes. And if we see that's 1296, that's certainly something that we could compute all of the possibilities for, right? Like I could list out all of the different combinations, and then what I could do is just say in how many of these is the biggest value 5. So kind of the naive way of doing this, or how we might first think to do it, is, well, I want to imagine I have kind of a tuple representing the results of the experiment each roll, right? So kind of the way we might want to do it is I could say for, let's say, I in range 1 to 7, again, because the first die has 6 possible outcomes, 1 through 6. Then I could say for j in range 1 to 7, for k in range 1 to 7, and for L in range 1 to 7. And already kind of alarm bells should be going off in that, look how much I've repeated myself. So this certainly is not dry code. And I should be thinking, okay, there has to be a better way to do this. And certainly we will see there is a better way, but just for the sake of kind of finishing this argument, let's say I call this, so I'm going to create a blank list called all dice. So empty list. Then what I'm going to say is I'll take all dice dot append. And what do I want to append? I'm going to append I, J, K, and L. So I'll run this, and then just to check, I can say, well, what's the length of all dice? And we can see here it's 1296, so exactly what I expected. So I've gotten all of the possible outcomes. And just for good practice, let's kind of take a look at, I don't know, let's say the first 10 entries here. So this is really good practice for iterating through for loops by hand. So remember, what's going to happen is first I is going to be set back to 1, and then we do everything after. So j is going to be set to 1, do everything after. K set to 1, do everything after. L is going to be set to 1. Then it's going to increment to 2 while everything else stays the same, then to 3 while everything else stays the same. So the first couple of elements, I should see 1, 1, 1, 1 with only L changing, and then we'll see K changing. But when I do all dice, and I just want to look at the first 10 elements, I and J should be 1 the whole time. So indeed here I can see 1, 1, 1, 1. Then we see L gets updated to 2, 3, 4, 5, 6. Then K gets incremented to 2, and we repeat the cycle 1, 2, 3, 4, so on and so forth. So if you're struggling at this point to kind of trace through, I highly recommend going back to the video where we talk about tracing through for loops by hand, or just pausing here and staring at this until it clicks. But now that we've seen this, and we've kind of talked about how this is a very inefficient way of doing this problem, let's introduce a slightly different way to do it. So what we're going to use is a module called itertools. So it comes with Python, so you won't need to install anything, but what we will need to do is say import. Now typically we're used to saying, for instance, import, we're going to be using something called itertools. And this would be importing all of it, but we don't need everything. So I'm going to say from itertools, because we're just going to be using product, so I'm going to say import product. You can see here, no issue. So then, like I said, we're going to be using product. So let's go help on product and see what it tells us. So we can see here, it's going to give a Cartesian product of the input iterables, and the repeat here is what we're going to be interested in. So we're going to kind of pass it our, what do I want to say? Our range 1 to 7. That's going to represent kind of 1 dice, and then we're going to repeat it 4 times. So because that's a lot kind of to go through, let's do it with a smaller number just to start. So for instance, let's say I do product, range, again 1 to 7 because I have 6 sides on a die. And then I'm going to, let's just say repeat equals 2. So notice here this returns what's called an iterator. So it's kind of difficult to get a grasp of what this is. So what I'm going to do is actually cast it to a list. So I'll copy this. And what we should see is it's going to go through all possible combinations of roles. So it'll have 1, 1, 1, 2, 1, 3, so on and so forth. So let's take a look. And certainly we see here we have 1, 1, 1, 2, 1, 3, up to 1, 6, and 2, 1, 2, 2. And we can see here it's given us all of the possibilities. So remember, what we want to do is, instead of repeating 2 times, so here this gave us just these 2 entries, we're going to want to repeat it 4 times. So let's have, I'm going to call it temp list equals, I'm going to convert it to a list, product of, again, range 1 to 7, and I want the repeat to be equal to 4. Before we kind of do more, I want to show you a couple other things. So we don't need to do product with just kind of one iterable like this range and repeat. We could also do something like product of A, comma, B, comma, C with, let's say, 5, 6. So if you've taken Math 13, this will be the Cartesian product. So it's going to take A, comma 5, A, comma 6, B, comma 5, B, comma 6, and so on. Again, let's look at this in list form. And we can see here 6 elements because there's 3 possibilities here, 2 possibilities here. So we have A, comma 5, A, comma 6, B, comma 5, B, comma 6, C, comma 5, C, comma 6. And what we could do is when we say repeat, it's really just taking this A, B, C with itself 3 times. So for instance, notice if I do, let's do product of A, comma B, comma C, and I say repeat equals 3. This is what I get. Versus, so now I could do list of product. So again, I don't want to kind of type this out a bunch of times, so I could just say ABC, comma ABC, comma ABC. And we can see here we get the 27 elements, so I could do length. This guy is 27, and it matches this one here, which also should have length 27. So a little bit of an aside on how this product works, but now let's go back to our original questions. Remember, temp list here holds all the possible outcomes of rolling 4 dice. So now remember we were interested, well, how many of these has 5 as the maximum? And maybe just to double check, I'm going to check the length of temp list. And remember we wanted 1296, and here we get 1296 because that represents all the possibilities. Now what we're going to do is I'm going to call, let's convert temp list to a NumPy array. So I'll say ARR equals np.array of temp list. And I can check the shape of array, right? So let's think about what it should be. So remember there's 1296 outcomes, and each one has 4 entries. So it should be 1296 by 4. And that's exactly what we got here. So now, remember we want to ask how many of these have a maximum of 5. So I can say ARR.max. Now remember, we want to move horizontally, right? Because each row represents a trial. So we want to say along axis equals 1. And I want to ask, well, when is this equal to 5? So this gives me a Boolean array. And remember, in the previous video, we wanted to take the mean because false is 0, 1 is true. So we sum up how many true, and then we divide by how many rows there are. So that's 1296. So if I do dot mean, I can see here, I get about 28%. So this is our exact probability. We could also do it mathematically, so without needing to kind of iterate through every possibility. And the way that we can think about it, and this is just an aside, so I'll call this mathematically. So let's think about it as I want 5 to be the maximum. So that means when I roll 4 dice, that 6 doesn't show up. So the probability that 6 doesn't show up is 5 out of 6 to the power of 4. And now I want to ask, well, I want 5 to be the largest number that shows up. So I'm going to subtract the probability that there's no 5s or no 6s. So minus the probability 4 out of 6 to the power of 4. And we can see here, this is exactly the number that we had gotten here. It looks a little bit different, but I believe that's probably due to some rounding error somewhere. But here's another way that we could have computed the same thing. I think this is a good place to stop the video. Thank you for watching, and I will see you in the next one.